In this video, we will talk about the section 7.2, Integration by Parts. Integration by parts formula says that the integral of u dv is equal to uv minus the integral v du. This is the most common form of the integration by parts formula. The idea is to choose u and v so that the integral on the right hand side is simple than the integral on the left hand side. This requires practice. So now let's do some example. Example 1. Find the integral x ex dx. So now we want to choose u and v so that this integral has the form the integral u dv, right? So we let u is x, dv is ex dx. So then we have the derivative of u, du is equal to dx. V is, we know dv is ex dx, so v is ex. Now the original integral, the integral ex dx is equal. So here this is u, right? Then this is dv. So now we use the integration by parts formula. It is equal to u times v. So it's x times ex minus the integral v is ex dx. So this is u v minus integral v du. So now we continue. We have this is equal to x ex minus the integral of e2x dx is ex, then plus the constant c. So this is using integration by parts formula to integrate this integral. So from here we can see that the most important part to use the integration by parts formula is to choose u and dv. So you'll see that once we have choose the u, then whatever left is dv. So now let's move to the second example. The integral x squared e to x dx. So for this one, we still let u be the polynomial x squared, then whatever left is dv. dv is e to x dx. So then we can get du is 2x dx. V is e to x. So the original integral x squared e to x dx. So this is u and this is dv. So this is equal to, by the integration by part formula, is equal to u times v. So x squared e to x minus the integral v dx. So ex v du, so minus the integral v du. So it's 2x dx. So this is u v minus the integral v du. Now we continue to simplify. We have this is x squared e to x minus 2, then x e to x dx. So you see the integral on the right hand side, this one, the integral as e to x dx. To evaluate this one, we need to use the integration by parts formula again. So we'll also see that we already did this integral in the first example, right? We know this integral is equal to this one. So we have this is equal to x squared e to x minus 2 times x e to x minus e to x plus a constant c. So remove this parenthesis. We have x squared e to x minus 2x e to x plus 2 e to x, then minus 2c, right? So we can use another constant c, right? This c is negative 2c, right? So we can use the same constant. This c is also a constant. So from this example, we see that in some cases we may need to use the integration by parts formula twice. So use integration by parts formula here, and also need the integration by parts formula for this integral. Now let's move to another part. So the integration by parts also works for definite integral. So for the definite integral, the formula is the integral a to b u dv is equal to uv evaluated at a, b minus the integral a to b v du. This is the integration by parts formula for the definite integral. So now let's do an example. Find the integral 2 to 3 ln x dx. So for this one, we let u is ln x, dv is dx. So this is u, this is dv. Then I have du is ln x, its derivative is 1 over x dx, du dx, so v is x. So we have the integral of ln x from 2 to 3 dx is equal to by the integration by part formula. It's ln x times x, the evaluated at 2, 3 minus the integral of x times 1 over x 2 to 3 dx. So this is u dv is equal to u times v evaluated at 2, 3 by the integral v du. du is 1 over x dx. So this is equal to ln 3 times 3 minus ln 2 times 2 minus 2 to 3, 1 dx. So this is 3 ln 3 minus 2 ln 2. Then this integral is minus x 2 to 3. So this is 3 ln 3 minus 2 ln 2 minus 3 minus 2. This integral is equal to this. So it's 3 ln 3 minus 2 ln 2, then minus 1. Then we finished this example.